السلام عليكم ورحمة الله تعالى وبركاته. أهل الطيبين، أهل السودان الحنينين، من هنا من قناة المعرفة بنوصل لكم أحلى وأجمل التحايا الطيبة الممزوجة بالحنية والدعوات الصادقة لأنه تنجح وتتفوق وتعمروا سوداننا، وأكيد حنبنيه بيدينكم بأجيال القادمة إن شاء الله بنجاحكم وبتفوقكم. من خلال قناة المعرفة الليلة حنستعرض لكم إن شاء الله الرياضيات باللغة الإنجليزية، وحنتناول بعض الدروس ومقتطفات إن شاء الله نقدر من خلال هذه القناة أن نقدم حاجة تستفيدوا منها وتجيبوا لنا درجات إن شاء الله عالية ونفرح الوالدة والوالد وكل الأخوان وكل الأحباب وين ما كانوا. وكمان يا جماعة إحنا ما ننسى إنه في خلال هذه الظروف الصحية الكاسحة لكل العالم إنه نغسل يدينا ونحاول إذا ما احتجنا لطلعة ما نطلع، ونلتزم بالإرشادات الصحية وين ما كنا. فإن شاء الله حنبدأ الليلة الدروس طوالي حنمشي للباب بتاع circle. We are going to start from the chapter of the circle. We are just going to know ideas, general ideas about circle. I think not going to teach you the lesson but just a review. So we are going to start by a definition of a circle. So a definition of a circle, it's what? It's a collection of points that have an equal distance from a center, certain point. Certain point here means what? Means the center. So as you see here, there is a circle, and in the middle there is a center. So each place from the center to the circumference of the circle, they are equal. So here in the other part, we are going to see the elements of a circle, or as know, a part of the circle. So here, as you saw, here we have a center, and the black one is the circumference of the circle. So from the center to, from the center to the circumference of the circle, we have what? We have a radius. And here from a center to other circumference, it is what? It is other radius. Two radius give you what? Give you diameter. So there is other lines from the center, from the circumference to other point in the circumference, but not goes through the center as here, diameter. So this segment, we call it a chord. And there is other segment, it's outside of the circle, it is called a tangent. And the last part, it is what? It's an arc. An arc is what? It's a part of a circle. Then we move to other elements. There is a sector, and there is, as you see here, a segment. It's a part of a circle. Okay, guys? So we are going to take just a little bit of how to find the missing angle. You find it in every single final exam in math. So how can you find the missing angle? As know, it is an X. So I'm going to draw a circle here. I think boys like blue, so I'm going to use blue. So we draw a circle. Then after what we have in the middle here, it is a center. Then the first one, the first rule is talking about this angle, and it is known by a central angle because this is a center. So this is a central angle, and this is an arc. So we have a central angle and this one we call it circumference angle. What we call it? Circumference angle. So if this angle is X, if this angle is X, doesn't matter. So I'm going to clean it because I think it's not really clear. This is a central. And this is other one, it is circumference. So if this circumference angle is x, so the central angle will be 2x, okay? So if we have as a number, to draw other angle, for example, if the central angle is 40 degrees, so the circumference angle will be, in the exam maybe, it's x. So x equals what here? You know that if the circumference angle x, then the central angle is 2x. So the central angle here, it's given for you. So the circumference angles mean it is half to it. So x equals what? Equals 40 divided by 2. Then angle x equals what? Equals 20. You get it? Then we have other example. Here I'm going to give you the central and you find the circumference. So the central is, the circumference angle is 30. I know my handwriting is not well, so this is 30. So angle x equals what? So it is double the 30. Then angle x equals what? Equals double 30, so it is 60 degrees. I hope that these two simple examples remember you about the idea of the first rule. Then we move to the other one. And the other one is the same idea, but here it's not by a diameter. If this is a center and this is a diameter, okay, no problem. Then so here in the middle there is a center. Then after that we have what? We have a circumference angle. Here it is a circumference angle. So my student, this angle, you know it in other grades, it is a straight angle. Equals how many degrees? Equal 180 degrees. So this central angle and the above one here, the circumference angle, is what? It is a circumference angle. So it is half to 180. So 180, half of it, it is 90, as known by right angle. So may they draw it for you in the other side. Here a circle, and this is a diameter, and they ask you to find this angle. So they give you this angle is 30 degrees, and this angle is x. So find this angle. You know this is diameter. You know this is diameter. That means this angle, it is 90 degrees. So 90 plus 30 equals, so 90 plus 30 is, I think, 90, 120. So this angle x equals 180. From where I get 180? The sum of angle of triangle. This is a triangle. So you know in other grades that the sum of the angle of triangle equal 180 minus what? The sum of these two angles is 120. So angle x equals 60 degrees. Okay, my student? Then this is the second rule. Then we move to other one. When two angles have same arc and there are two circumference angles. So we have a circle, then this is a center, so this is a circumference angle, let us name it X, and there is other circumference angle, it's Y. So angle X equals to angles Y. Why they are equals? This is a rule because these two circumference angles, they have what? Same arc. So if this angle X equals, for example, 50 degrees, so angle Y equals be 50 degrees. Okay? Then I think we move to other rule because this is so simple. I can just give you another example in other side. So my circle's not well because I use my hand. You should use compass to draw a circle. In the exam, you are going to find the circle drawing for you. So there is an angle here. This is circumference angle. And maybe this one, other circumference angle. The vertex of this angle should be in the circumference of the angle. So if this angle is, let us say that it is 98. So this angle, it is L. So angles L equals what? Equals 89 degrees. Okay? So we move to other rule, just a revision. I didn't explain the lesson because you just took it before. I just review these lessons for you to be ready and get high mark in math because I think all of the students have a problem in math. So if you have any problem, you can text us to answer your questions. So the other rule, when we have, this is a square, and this is a rectangle, and there is a rhombus, and there is a parallelogram. So when we have like this quadrilateral figures, and they are enclosed between a circle, this is not a circle, of course. So here we have a quadrilateral figure inside a circle. So we call it what? We call it cyclic quadrilateral. So in other grade, we take supplementary angles and complementary angles. So the supplementary angles, that means there's sum of the two angles. Let's name here this angle, for example, x1. And the angle opposite to it, it is x2. And this angle is y1. And the opposite of it, it is y2. So in a cyclic quadrilateral, angle x1 plus angle x2 should be supplementary angles. Supplementary angles means their sum should be equals 180 degrees. Okay? The same in angle y1 and y2. So y1 plus y2 equals 180. Okay, my student? So we move to this square. You know, in a square, all of the angles are 90 degrees. So if this is 90 degrees, that means this is 90 degrees. And this one is 90 degrees, and this one is 90 degrees. So 90 plus 90 equals 180. The same in a rectangle. Then I'm going to give you other figure. So this is a circle, and here it can be like this. Okay, it's near to rhombus. So if this angle is, let's say, 80, I use simple numbers to be the idea be clear for you. So 90 and 80, and this is x. So immediately 180 minus 80, that means angle x equals 100. Okay, so this about the cyclic quadrilateral. Then we move to the exterior angle. Exterior angle, the outside angle of the cyclic quadrilateral. So let us draw. We can use this figure too. We don't need to draw other one. So, for example, if I make a line outside here, and this angle is an exterior angle outside of the cyclic quadrilateral. So, angle y from the rule say what? Angle y equals the opposite angle adjacent to angle y. That means this is angle x is the adjacent angle for y. So angle x is the adjacent, so the opposite angle to it, it is 80. That means angle y is 80 degrees. Okay? So there is a little proof. I love it, and I think it's all time in other exam, many exams, you will find this proof. So it's so simple. This is a proof, not find the angle. So there is a triangle inside the circle. And there is a line outside of the circle. This line, if you remember the elements of the circle, it's called tangent. So this tangent parallel to this side. So here it is x, and here it is capital A, and here it is capital B, and here capital C. So they want you to prove that angle ABC equals to angle BCA. Means what? They want you to prove this angle. Let's use the red one. They want you to prove that this angle equals to this one. So let us together get the steps of this proof. So the first one, we have the tangent. It is AX is given parallel to CB. Okay? And there is letter Z here. It is here. So in the kind of angles between lines, there is letter Z, but it is the opposite of it. So here, this angle, and there is this one. We know it before, like this angle, we call them alternate angle. So angle XAC, that means the exterior angle, equals to what? Equals to angle BCA. So let's write this. Angle XAC, the exterior one, equals to what? Equals to angle BCA. And the reason is, you're going to write it between brackets. I'm going to write it here. It is alternate O. Alternate. There there is E here. Alternate angle, then you close the bracket. So this is, we call it 1. Then we move to 2, and it is what? We move to other angle, it is B. So angle ABC, it is angle ABC. I mean this one. It's equal to what? It's equals to, by theorem, this angle and this one, they are equals from the last theorem. The exterior angle equals the opposite angle for its adjacent. So angle B equals to angle, this is equals to angle XAC. And the reason is theorem. There is E here. I know my handwriting not well, but get the idea. So this is 1 and 2. This is 2. From 1 and 2, we find that this angle equal to this one by alternate angle. They all alternate. And this one equals to this one. They are equals from theorem. So from 1 and 2, we find this equal to this angle, and this equals to this one. That means these two angles are equal. So from 1 and 2, from one and 2, we find what? We find that angle BCA, you should name the angle by 3 letters, not only one, equals to angle here C, so we move to be CBA, and they will ask you to prove. Okay? So we move from the circle to chapter 3 about powers and logarithms. So we clean this first. By the way, math is not difficult. It's about practicing. You work more problems, that means you make math easy for you. So we move to base and power. So for example, we have 4. 4 is 2 times itself, 2 times. So it is 2 square, or 2 raised to the power 2. If we write 16, it's about 4 times 4. That means 2 to the power 2 times 2 raised to other 2. 2 square, 2 square, 2 square. That means how many 2 are there? There are 4. So 2 to the power 4. So the first rule in the base and power, talking about when we have common bases, what we do, we add the powers. So let's get more examples here. Five raise it to 11 times 5 raise it to 100, for example. So what we do, you're going to add the powers only. So here 5, 11 plus 100. So it is 5, 111. Other example, easiest one, using letters. So channel المعرفة. So C to the power 20 times C to the power 1. So it is C to the power 21. we are going to see improvement in the other year and this year, inshallah. So when we have common bases, just we add the powers. We move to other one when we use brackets. Use black. So you have a number, rise it to the power m, and this rise it to other power, it is n. So what we do here, we are not going to add the powers. Many students, they say that we add, so m plus n, and this is totally wrong. So what we do, for example, number, rise it to 2, and it is rise it to 3. The rules say that we multiply the powers. That means n to the power 2 times 3. So it is n to the power 6. If we add the powers, we are going to get this result. N to the power 2, rise it to 3. Then it is n to the power 2 plus 3. That means equals n to the power 5, and this is wrong. Okay? So we can use numbers. Two times 2 cube times 2 to the power 6. So here we have 2 to no power. They didn't mention the power, but you should know when they did not write the power or the number, that means it is 1. So here that means this power is 1. So here the first rule, you add the powers. So 2 to the power 1 plus 3 plus 6. So 6 plus 3 plus 1, so it is 2 to the power 10. Okay? Other example for multiplying the powers, let's write 3 to the power 7, rise it to the power 4. So here we just multiply the powers, so multiply these powers together. So 4 times 7 is 28. So simple, and this question, repeat it many times in your final exam. So be ready for these questions. So we move to when we have same power. They ask you to simplify. So 3 to the power 9 times 4 to the power 9. Here new rule. So you have different bases but same power. So what you do, you're going to write 3 times 4 equals what? You can write the answer in the other step. So 999, you can write it here, and you multiply. 3 times 4 is 12, rise it to 9. But if it is addition, it's not correct. So if you write 3 to the power 9 plus 4 to the power 9, this is not equals to 7 to the power 9 or not equals to 12 to the power 9. This is totally different. Okay? So here about multiplication. Or it can give you the opposite. Give you what? 5 times 9, rise it to 2. So you can write it here, 5 to the power 2 times 9 to the power 2. Then you multiply 5 times 5, 25, times 9 times 9 is 81. Then you multiply these two numbers together and write the final answer. So this is the third rule. Then we move for division, and it is the end of this period. So when we have division, we have x to the power m over x to the power n. So equals what? The rules say that when we have same bases but different powers, you do what? You subtract the powers from each other. So we have x to the power m minus n. If we take them as the numbers, it is x to the power 9 over x to the power 2. So we can make it easy. Here 19 and here make it 9. To be simple for you. And here it is 9. So it is x to the power 19 minus 9, which is equals to 10. Here the power of numerator, I mean here a numerator, down is denominator. So if we make the opposite, I make the simple power here, the greater power in numerator, and the smaller power in denominator. Here I'm going to do the opposite. X to the power 9 over x to the power 19. So equals to x to the power 9 minus 19, which is equals to x to the power negative 10 here. We have negative sign for 10. So when we have negative power, we do what? It is already in numerator. So what we do, we change it to be in denominator. So it's equals to 1 over x to the power 10. So this is the difference between when the powers in numerator greater than the power in denominator, and here denominator powers less than denominator powers. So the third case is when they have equals power. So if we choose the same numbers, but here I'm going just to take 19 over x to the power 19. That means x 19 minus 19, it is 0. So it is x to the power 0, because 19 minus 19 equals 0. So any number, raise it to 0, equals to 1. Okay? So this is our lesson, general lesson in chapter 9 and chapter 3. We select the circle, how to find the missing angle, and the base and the power. So see you next time, and stay home and be careful. See you.
من أعراض الإصابة بفيروس كورونا ارتفاع درجة حرارة الجسم اللي هي الحمى والكحة وضيق في التنفس.